This is Geometry, Chapter 8, Lesson 1 on page 298. This lesson is all about transformations. What is a transformation? Can anybody tell me what a transformation is? Yes, Landry.
It is a one-to-one correspondence between two sets of points.
Okay, what does one-to-one correspondence between two sets of points mean? What does that really mean? That means I have an image, right? I have an image, either a three-dimensional or a two-dimensional image. And I move the exact same image to a different place, a different space. From here to here, I rotated it. Get it? This is a rotation, like a cartwheel, right? All right, look, from here, so that's a rotation, such that the top is not always at the top with the rotation, right? It can move different places. All right. A translation, the image doesn't rotate at all. It goes from one place and I just slide it over. It's almost like a slide. Got it? Here to slide. All right, when you go to the eye doctor, what do they sometimes do to your pupils? They dilate them. What happens to your pupil when it's dilated? Huh? They get larger. That's a dilation. Okay, but guys, a dilation can go from small to big or from big to small. The angles don't change in a dilation. The angles stay the same. The image is just larger or the image is just smaller. All right? So we have a translation, which I'm just moving the image from one place, and it stays, the top is the top, the bottom is the bottom, left is the left, right is the right. You don't change that. It just slides to a different position. All right, I can have a translation. This is the way a lot of geometry books do it. I can have a translation of a triangle, and I could translate it to here, such that this, if the triangle original is ABC, then the new triangle is A prime, B prime, C prime. The image is those little, it's not an apostrophe, it's called prime, okay? A prime, B prime, so the image has those apostrophes after it. That's a translation. I could translate it anywhere. I could move it up here, right? And this could be A prime, B prime, C prime. Okay, I just slide it. A's always at the top. That's a translation. Does that make sense? And all of these angles stay the same. That doesn't change, right? All the angles stay the exact same. The length of AB stays the same. Every angle, every length stays the same in a translation. You're just sliding it in one direction. Make sense? Translation. A rotation, I would actually turn it around. Okay, I'm probably changing the length and the angles, but it doesn't. So I could rotate it, and this would be A prime, B prime, C prime. This could be a rotation, so that A is not at the top anymore. I can rotate it here. I could actually, you could rotate it a multitude of places, right? I mean, I could go here and I could just slide it here and that's a rotation. Does that make sense? I could go here and I could slide it around to here and that could be a rotation. Does that make sense? So with the rotation, the figure is not, A is not always at the top. It's somehow rotated around. Does that make sense? A dilation, so a dilation could be, that could be a dilation. What happens in a dilation that's different from a translation and a rotation? Yes. Ari?
The triangle will get bigger or smaller.
Correct. So the angle stays the same. The lengths of the sides change. Angles remain the same, but the lengths of the sides change proportionately. Yeah, so it could be either that or both of these are dilations of the original. The angles remain the same. The lengths of the sides either get larger or they get smaller. So there's this new word. It's on page 300. It's under your definitions. It's called isometry. A new word. Isometry. An isometry, an isometric transformation is a transformation that maintains distance and angles. So distance between the two letters and the angles at every vertex. Okay, so we've talked about 3 transformations. One is a transformation. You're just moving it, sliding it. The top is still at the top. The bottom is still at the bottom. Sides still at the sides. That's a transformation. That's a translation. A rotation, that means the orientation changes. And then there's a dilation. One of them is not an isometry because it doesn't maintain distance and angles. Which one is it, David?
Dilation.
A dilation, that is correct. A dilation is not an isometry. A rotation is an isometry, and a translation is an isometry. But a dilation is not an isometry because it doesn't maintain the distance. AB, the length of AB, changes. The distance between those vertices changes with a dilation. Does that make sense? It is not an isometry. All right, so look at your transformations cheat sheet. And then we're going to do some transformations. All right, look what a reflection is, which is not covered here. Actually, it's covered a little bit in the middle of page 299. All right, so with a reflection, we're going to do some reflections too. Okay, I'm going to draw a right triangle. It's easier to see reflection with a right triangle. A reflection is also an isometry. All right, let's say this is my right triangle. And I want to reflect it across the x-axis. Okay, if I reflect it across the x-axis, the x-axis becomes like my mirror. You know, when you look in a mirror, the closer you get, what does it look like? The bigger the image, the farther away, the smaller both images, you and the reflection, right? So they maintain this isometry. All right, if I were to draw this and reflect it across the x-axis, now this would be A prime, B prime, C prime. Does that make sense? If I reflect it across the y-axis, this is A prime, this is C prime, that's B prime. All right, so the one closest to the mirror, our point of reflection, is going to be closest on the other side. Does that make sense? The one furthest from the mirror is going to be furthest from it on the other side. Make sense? All right, so reflections are like a flip, right? We do this. Look, it's this way, then it's that way. Make sense? It's this way, then it's that way. Almost like a flip.
Can we not reflect it into quadrant 3?
You absolutely can.
You can.
Yes. Can I? That might be a little hard. That would be it from 1 to 3. Because where would my mirror be? My mirror would be here.
Right.
So I'm going from here to here. Does that make sense? All right, the flip is across a line of reflection. That's this mirror, right? That's why I drew this yellow. If I'm going to from quadrant 1 to 3, you have to think of the mirror. So I'm going from here to there. So every reflection has a line of reflection. Reflections are isometric, but don't preserve orientation. The only one that preserves orientation is the translation. Preserves orientation. That's the only one. Reflections don't preserve orientation. All right, so look at these coordinate rules. These are key. Your textbook does not do this enough. So if I'm going over the x-axis, what changes? For C, the x coordinate doesn't change. But the y coordinate is the negative. So, do you see that? If the C coordinate were 2, 1, then the coordinate point of C prime would be 2, -1. What changes? The y. You see that? Over the x-axis, what changes? The y coordinate. Sometimes this is on the ACT. It's not in your textbook, but you will be required to know this. All right, so if I'm going across the x-axis, the y changes. If I'm going across the x-axis, the y changes. Okay. So what do you think happens if I'm going across the y-axis?
The x changes.
The x changes. That's right. So what would C's coordinate point be here, David?
If what?
This C prime.
Would be 1, 2, 1, 2.
Well, does my y change? Y doesn't change. What happens to the x?
Oh, it's negative.
-2, 1. Do you see that?
Yeah.
Does everybody see that? Just giving you a minute. So, for reflection, reflecting it across the x-axis, the y becomes negative. X stays the same. It's just the opposite, right? Reflecting it across the y-axis, the y stays the same, the x value is negated. Yeah. Can you wait just a minute? Okay, now look here. Okay, from quadrant 1 to quadrant 3. That's over the y equals x. That's not the y equals x. That's through the origin. xy becomes negative xy. Okay, what do you think the coordinate point of this C is? We can go from here to here. Across the y, across the x, what changes? Across the x, the y changes. So what would C be? -2, -1. So from 1 to 3, what happens? From 1 to 3, what happens?
They both negate.
Both of the signs negate. So from 1 to 3, both signs negate. From 2 to 4, what happens? Same thing. Both signs negate, don't they? -2 becomes +2. 1 becomes -1. So it's both. 1 to 3 is the same as 2 to 4. Okay, so we have reflections. Translations. Translations are a slide or shift. We're not going to look at that middle thing until a couple more lessons. They are isometric and preserve orientation. All right, so back to the original image. All right, so if I have point C, 2, 1. Okay, I got to make up other points. And let's say this is maybe 6, 1. And this is going to be 2, 8, 2, 8. All right, those are the coordinate points. Okay, translations we do all the time with graphs. So if you can get this translation deal down, we translate graphs all the time. So we're going to tie this into when we get to Algebra 2 and when we get to pre-calculus. You're going to have to understand translations. All right, let's say I want to move it left 3 and down 2. Left 3, down 2. Okay, where does C go? What's the new coordinate point for C? I take 2 minus 3. So my C prime is going to be -1. Left, right changes my X value. All right. My Y value goes up or down. So what's going to be my new Y value? -1. Okay, what's going to be my new A coordinate? What's the X value going to be, Isabella? -1. What's going to be my Y value? 6. Are you getting this?
Yeah. You're just subtracting.
Well, right, because I'm going left and down. If I were going up, what would I do? Add. If I were going right, what would I do? Add. Got it? All right, what would be my B prime? What would be my X value for my B prime? Yes, David?
Would it be 3, -1?
3, -1.
Is that right?
3, -1. Yes. Okay, got it? Okay, that's translations. Look at dilations. They're enlarging or they're shrinking. We're multiplying the distance from the point of the project. So if I'm going to make this twice the size. Twice the size. I'm going to enlarge this by a factor of 2. You multiply by 2 each coordinate point. So what's this new coordinate point? 4, 2. 4, 16.
12, 2.
12, 2. Got it? You're multiplying. What if I'm shrinking by 50%? So I want 1/2. What's this coordinate point? 1, 1/2. You get it? This would be 3, 1/2 and 1/4. Got it? You're shrinking or enlarging. You're multiplying by whatever your dilation is. Rotations. Okay, rotations are a turn. We're not going to read that middle one, but they are isometric. They do not preserve orientation unless the rotation is 360 degrees. Did you know you could rotate 360 degrees?
I didn't know.
Yeah, you can. You can rotate -360 degrees. You can rotate 720 degrees. We will do that when we get to pre-calculus. Vectors. It has to do with vectors and trig.
No, it was all 40.
Okay, yeah.
My fault.
Okay, look at the very bottom one. Rotations of 180 degrees are equivalent to a reflection through the origin. Okay. So everybody look. This is 0. The positive x-axis is always 0. And you count counterclockwise when you're going around. If this is 0 degrees, how many degrees is this? It's 90. How many degrees is this?
270.
180. This is
270.
all the way back around to
360.
360. All right? Now, if we rotate this 90 degrees, what happens? We're going 90 degrees counterclockwise. Okay. 90 degrees counterclockwise is the same thing as 270, negative 270. Okay, we're just gonna look at the positives. Don't look at the negatives.
Yeah.
We will. We will, actually. I mean, my pre-calculus students already know all that, the clockwise. You have to know that when we get to pre-calculus. All right, but counterclockwise, the 90 degrees, the XY goes to, so this C, this 2, 1, your XY, look what happens to it. It's negative Y, X. You see that? So it's negative 1, 2. So negative 1, 2 would be like up here. That would be C prime. Got it? You swap them and you negate the new X coordinate, which is the old Y coordinate. You see that? Does everybody see that? So X, Y becomes negative Y, X for a 90 degree. So the 2, 1, I swap them, becomes 1, 2, but this first one is a negative. Okay, we're not gonna do a lot of rotations. 180 degrees, look what happens. Both of the signs change, but XY just becomes negative X, negative Y. That's always the case with the 180 degree rotation. It puts it in this third quadrant. If I do 180 degrees from the first quadrant, it's like two reflections. A reflection across the Y, then a reflection across the X. And if I go from 270 all the way around to here, rotating it around, the same thing happens, but the X changes instead of the Y. All right, not going to focus a lot on that.